this video, we will explore Pythagoras Theorem, and you will learn what Pythagoras Theorem is, how we can apply Pythagoras Theorem to everyday life, and how we can use Pythagoras Theorem to find unknown sides of right angle triangles using the plus minus method. What is the plus minus method? Stay tuned and let's find out. Okay, now let's go through the basics before we investigate the plus minus method. Pythagoras theorem. What is Pythagoras theorem? Before we get into that, here we have three right angle triangles. But first thing you need to know what a right angle triangle is. A right angle triangle is simply a triangle where one of the angles is a right angle, such as this one, and the other triangle that you're seeing. The side directly opposite to the right angle is what we call the hypotenuse. So here, the hypotenuse is this side. So we'll shorten it by writing HYP. The side opposite the right angle is my hypotenuse. Now, according to Pythagoras theorem, if we have a side A, B, and C, then the square on the hypotenuse is equal to the sum of the squares of the other two sides. What do we mean by that? Simple. The hypotenuse here we have C. So C square is equal to A square plus B square. It is simply the hypotenuse square equal to the other two sides squared. And we can use Pythagoras theorem to find an unknown side of a right angle triangle given its other two sides. So we will use the plus minus method. Stay tuned because this is a very amazing method to find unknown sides of right angle triangles using the Pythagoras. So here we have the plus minus method. In order to find the hypotenuse, this side, the longest side of the triangle, we add the squares of the other two sides, or we find the sum of the squares of the other two sides. And if we wish to find either the other two sides, we simply subtract. Now let's get straight into an example. So the first example here, the hypotenuse is x. Again, we identify the hypotenuse by just identifying the right angle here. The side directly opposite to the right angle is my hypotenuse. So the unknown side is x, the hypotenuse. In order to find this side, according to the method that we'll be using, we add the squares of the other two sides. So this is how we started. X squared is equal to 7 centimeters squared plus 4 cm squared. Again, we're finding the hypotenuse. So x squared is equal, when I square 7 cm, we'll have 49 centimeters squared plus 16 centimeters squared. The next thing we will do, we'll simplify this. So x squared equal to 49 plus 16 will give us 65. Cm square plus cm square will give you cm square. At this point in time, we need to solve for x. Here we have square. So here we will apply the root to x square in order to get rid of this. What we do on the left, we do on the right. The root of 65 cm. What happens? The root will get rid of the square. So all we have now is x. X is equal to the root of 65 cm square, and the result is 8.1 cm. Correct? To one decimal place. We'll go on to the second example. The second example here, we're seeing that the unknown side, in this case, is not the hypotenuse. The unknown side here is AB. We need to find AB. As in the first example, when we don't have a labeled triangle, such as the second one, ABC, we just simply start at our unknown and we continue just as what we would have done. Now for the second example, however, we have a well-labeled triangle. So the hypotenuse, the side opposite the right angle, is AC, and the length of AC is 12 cm. BC is 6 cm, and AB is what we need to find out. We need to find the length of AB. And like I said before, if we are not finding the hypotenuse, if the unknown side is not the hypotenuse, we simply subtract the squares of the other two sides. Let us do that right now. So AB square, what we need to find out, equal to AC square. Why AC square? Because 12 is the larger number here. We have 12 cm and we have so AC square minus BC square. And then we substitute. It is important for you to start this way, whether you're doing your GCSE or CSEC mathematics, your GED, wherever you are, it's one common language, the mathematical language that you need to understand. If you're telling the examiner this is what you're using. So let's continue. AB square is equal to, now AC is 12 cm. So we simply write 12 cm square minus BC is 6 cm. So we write 6 cm square. AB square is equal to, when I square 12 cm, we'll have 144 centimeters square minus 36 centimeters square. So here we have AB square is equal to, when we subtract 36 from 144, we have 108 centimeters square. Again, we'll apply the root to AB square in order to find the length of AB. So AB is equal to the root of 108 cm square. Again, you square this side, root it rather. So AB is equal to, when I root 108 centimeters square, we have 10.4 cm. A point to note for questions 1 and 2, when you root a number, you'll have plus and minus of that number. But since the side of the triangle, we cannot have a negative side such as negative 12 cm or negative 6 cm, then we take the positive root of that. So we end up with 10.4 cm. For next question, we will apply this to real life. So here we have a ladder and a very good looking wall, and we have our grass. There you are standing and you're painting your wall. Then up comes your friend. He's admiring your work. And guess what the question is? Hey, what's the height of that wall? I want to build a wall similar to that. You don't have your measuring tape to measure the height of this wall. However, you know that the ladder, the length of this is 6 meters. Then you want to place the ladder in such a position you don't want to fall. You put it at a suitable distance between the bottom of the wall where the base of the ladder should be. So the distance between the base of the ladder and the wall is 3 meters. How do we determine the height of this wall? We can use Pythagoras Theorem in order to determine the height of this wall. So what we do, this is an unknown side. You can just say let y represent the height of the wall, or let x represent the height of the wall, or let p, let anything, once you state that on your paper. In this case, let p represent the height of the wall. P square, again, in this case, the hypotenuse as we're seeing here, the wall and the ground, a right angle is formed here. the angle between the wall and the ground. So we consider this a triangle. The hypotenuse is the ladder. So the length of this ladder here is 6 meters. And the distance between the base of the ladder and the bottom of the wall there is 3 meters. So we need to find the height of this wall. Your friend is sitting there and he wants to know, hey, what's the height of that wall? So let P represent the height of the wall. And of course we square it. So P squared, once we're not finding the hypotenuse, we simply subtract the squares of the other two sides. So P squared is equal to 6 meters squared minus 3 meters squared. P squared is equal to 36 meters squared minus 9 meters squared. So P squared is equal to, and when we subtract this, we have 27 meters squared. Again, we want to find P. P represents the height of the wall. So your friend is waiting there patiently. And we apply the root to both sides of the equation here. So I root P squared and I root 27 meters squared. When I root P squared, we end up with P is equal to the root of 27 meters squared. And this is 5.2 meters. Back to 1 decimal place. So this is Pythagoras Theorem. Very, very easy. We use this to find unknown sides of right angle triangles. When given two sides, we simply use Pythagoras Theorem to find the third side. I trust that this video was beneficial to you and you understand now how to apply Pythagoras Theorem in everyday life and to find unknown sides of right angle triangles. So thank you for watching. If you haven't yet subscribed, please consider subscribing, sharing the videos, and giving the videos a thumbs up. Goodbye.